Let's develop another model. A small warehouse provides work-in-process storage for a manufacturing facility that produces 4 different part types. So we have 4 part types like this. And then part types, percentage, and inventory cost per parts are shown in this table. Got it? And then the interpretation of the inventory cost per part is as follows, and each part in inventory contributes an amount from the last column of the above table, and then total cost of an inventory being held at the moment. For instance, if current inventory is 3 units of part 1, none of part 2, 5 of part 3, and 1 of part 4, then the current inventory cost is like this, 67. Okay, $67. Good. So you need to multiply the unit cost per part by the number of parts, okay, the inventory. And as a part alive and depart, as described below, this inventory cost will rise and fall. Part alive with the triangular distribution interval times. So, and then the first part alive at time 0, like similar to the other modeling problem, and then 2 crane store and retrieve part with the travel time of uniform distribution here, each way. Request for the part removal alive with triangular distribution, interval time, and independently of the alive process for part, and the first request arrives at time 0. If no part is available, the request is not filled, okay? And all part requests are given priority over part storages in terms of getting the use of crane, and priority is given to retrieving based on the highest part cost. So for part arrival, increment the inventory cost upon arrival, and increment the total number of parts in inventory after the part is stored. Yes, it's a kind of complex, right? And for part request decrement the total number of parts in inventory as soon as you know there is a part to retrieve, and decrement the inventory cost after the part is retrieved. So run your model for a single application, length of 5,000 minutes, starting with 4 of each part type in the warehouse. Collect statistics on crane utilization, the average inventory cost, the average number of each part type in warehouse, and the number of unfilled requests due to having no parts of the request type. Okay, so you need to utilize all your skills to develop the simulation model. Yeah, it's not really easy problem, but you can do it, I know. Anyway, so let me give you the example like this. So you can create initially you can create the part, okay, and then also you can assign the cost, right? And basically in my case I utilize the variable, okay, also the attribute like this, and here you need to have 2 other create modules. So this one is a part create, and this one is an initial part create. Okay, you can see the difference. And then part type and cost assigned, storing process, total cost, and number of parts assigned, and part hold, retrieving seize, delay, release. I use this one, and then total cost to use a shared queue. So that's why total cost and number of parts assigned is here, and the dispose. And similarly, you can also like a cutoff logic. You can create another crane. You can use another crane module to generate the retrieving request here. So request is generated, and then if any part in the inventory, based on the availability of the part in inventory, it will send a signal or not. Okay, so here we send the signal here so that this hold module can receive the signal from this logic module, and then based on the request, basically based generated in this module, and then it will release one unit of the part. Okay, got it? So something like that. So you can have different modules to solve this problem, and it's not really, it won't be matter. I just want to see how you can solve this problem based on your knowledge. Thank you.